Vande Gujarat.
Hello, welcome all of you. Today is the third day of first session of our TV show on mathematical concepts. So, interactive TV show on mathematical concept, and myself Chanchal Das, and this is an initiative from Das Math Lab. We are trying to promote mathematics globally and among the masses. So, our approach of teaching mathematics, you can show the slide here. Yeah, this is the interactive TV show on mathematical concept, and next slide I can change or. So, we are working to provide this high quality mathematics education to masses, and definitely it is not going to be in conventional way, because conventional way we teach mathematics every in micro level, I should say. Every aspect of mathematics is being taught step by step from class 1 to 12. But when we talk about that teaching mathematics to masses, we cannot go in that direction. So, what can be done for that? So, what we are trying to do, we have trying to do in teaching mathematics from the macro level. So, what is that macro level? Macro level means we are trying to we are trying to give a picture, a holistic picture of entire mathematics required for our daily life, and from that perspective, if we see this what is mathematics, then learning mathematics will be much more easier, and then you can correlate every of your learning with the life, real life. So, whenever you require any real life problem, actually we are applying mathematics. Whenever we are required to perform any mathematical concept, we are required to solve some mathematics related to that, but we do that effortlessly, we never face any problem. But when it comes for appearing exam, we fail miserably. So, there is something mismatch between the mathematics of our life and mathematics which is being taught or appear in the exam question paper. So, hello, I think there is a echo, I think. Hello, hello. Some echo is coming, I think. Now it is okay. So, so this is with that I will start. So, where to start and how to start in this macro level mathematics, that is most important thing. Macro level picture of mathematics, and all starts with simple observation of that pattern, everything having a pattern, and if we can identify this pattern, then we can see from that pattern and we can solve the problems related to that system. And in our class also we are being taught this pattern throughout, and it starts from class 1. Actually, when we pass out, we forget about what is being taught of us and how we proceed for mathematics learning, but first we start learning mathematics from the pattern. Class 1, if we start, I have today brought some books in class 1. This is class 1 book, NCERT book, And you see this title of this book is not mathematics, it is math magic. So you can see that it is a funny way of making awareness about mathematics, not exactly teaching mathematics. So in this this is chapter 10 is totally devoted with a pattern, and these patterns actually, when you can see this these patterns starts with some geometrical shapes, and later pages in class 1 itself this pattern they start shifting from this geometrical shape to numbers. So different numbers here. So pattern, and this starts from 1, 2, 3, 4, 5 continuously you will get this pattern. After 6 I think or 7 there is no chapter on patterns, but student we learn these patterns mechanically without much attention why we are learning that. So that is one of the weakness, and we should overcome that. And second thing, it is class second book, this is also math magic, and here also this one chapter is a pattern, chapter 5, and this is also page 30. These are all patterns, it is and third chapter, third class 3 book. Class 3 book, this class 3 book is this is a Bengali medium, but it is also NCERT book, and this NCERT book I should say very nice books, and they publish every year. And nowadays this Gujarat government is following this NCERT mathematics books, but they have translated in it in Gujarati. So now these books are available in Gujarati and as well as English, and Hindi and English was there earlier. Now Tripura government, they have also adopted this NCERT syllabus, and they have translated all the NCERT books into Bengali, and so this Bengali NCERT books in Bengali also available. But this is also titled not Ganit, it is Ganiter Maja, means math magic and Ganiter Maja, that is the thing. I could not collect this book from Gujarati. I will next class I will bring some books. But here the first chapter what I want to emphasize is that pattern is there continuing from class 1 to 2, and this first chapter it is where to look from, this is where to look from. And first this figure, this is a car which is appearing like a box, actually it is a car, and it is looking from the top view. So you can see at early days we are encountered this visualization problem, visualization of our world, when we see the world how it will 3D world will look like. So this starts, and some tables and table, when you see a table from the side you will see like that, and from the top if you see it will see a square rectangular sort of thing. And then there are some other staircase, how staircase look like from front view this, side view this, and you can see this how it looks like. So like that visualization. So these are the things. So what I want to emphasize is that these three things, one thing is pattern identification, then visualization. These two main activities means what we require for learning mathematics. And the most important point is that if you want to popularize mathematics, you have to draw some means, so that you can engage the students. If the students are not engaging in any activities, then all these things they cannot learn. It will be learning for learning sake. They will not real sense it. They will take benefit out of it. So, how to engage, and how to engage, for that last 2 days I have narrated two problems in real life, which starts very early days. All of us are interested in solving Sudoku, say filling the magic squares and all these sort of things in with numbers. So, with that if we can engage students, so two activities I will write that. Today is 11 December 2022. So, one thing is that pattern identification is one of the most required thing, and second thing is that visualization, where to look from. If these two activities any students can learn properly, then he can be master in mathematics. So, what to do for this? So, two are the activities where I feel we can help the students to get engaged. So, second thing what is required, we require to engage them. This is the most what I give emphasize on that. You have to have drive some means to engage the students. Once they start engaging themselves, it is not that force engagement, they voluntarily come and start working on that. So, this engagement, if you can start encourage the students and engage them, then you will be successful as a teacher in teaching mathematics and for the same sex science and any other subjects. So, engage. So, how to engage? This is the thing, and I am looking at teaching mathematics in masses and from the macro level in the sense from the broader sense. So, in the broader sense what we can do to engage. So, this is the ideas what I am trying to one thing is I am giving some suggestion, and I will inform, I will explain why I am suggesting these two activities. This is there can be many other activities. I will subsequent classes I will explain that, but today I will be giving first 2 days also I explained on those things. Two things I will be explaining today again. What is that? One is this magic square. This part I have discussed last time, magic square, and magic square, when we talk about magic square, what is this and how we can help students to get engaged, and how earlier days people used to do these things, then I will discuss all these things, and subsequently I will go to that making model of a tetrahedron. So, I will be doing these two activities, and while doing tetrahedron, I will be doing a physical model, and then one geometrical or mathematical model. I tell is a geometrical model, and if we can do both, then we can solve any mathematical problem what I feel what is required for our solving our daily life problem. And with this I want to save this. I think this will save yes, then no, cancel. Yes, it is saved. So, these two activities I want to do today, and for doing this I will start with the magic squares, and magic squares what I will be doing, I will be showing some books on this, and this can you zoom a little bit? Okay. So, this is the handwritten from the notebook 1 by Srinivas Ramanujam, and these are the first notebook, first chapter. So, there are so many ideas about this, and then this is another book, and this is also first chapter of second notebook of Ramanujam, and his ideas here. So, today we will be will try to explore few of his ideas, and but not very elaborately, using technology, because they have done. And before that there is another book I have. This is also magic squares in India, and this is very good collection of many magic squares we practice in India from the long time. And here is a Nagarjuna squares. I will try to show that. So, with this I will I will try to explain it, but they have Nagarjuna, as I have seen, there are controversy about the ages he existed. It is Wikipedia, it is mentioned that 1100 years ago he written his book, but somewhere we mention he was much more earlier than that. But that part is separate part, that is his historical part, and we are not going much on that. But we will be showing that how he used to solve. But at his time there was no technology, nothing. He has to depend on his intellectual capabilities, mental eye, on his everything. But we do have today lot of technology with us, and how technology can be used in solving this or filling this magic squares, that I will be showing 2-3 cases, and today. So that a student can get engaged with that with technology, how it can be solved using technology. That is first part I will be doing, and then I will be talking about this making model. Today I may not finish this. I think it is required some. When we go for this physical model is very easy, we can do anytime, but if we go that geometrical modeling using Excel, then it has a lot of ideas, new ideas which is required to learn, and step by step I want to teach that, and so that these ideas you can apply in any of your problems in real life. So, with that today I will be starting my presentation on Excel for magic square. So, this is my Excel file, and Excel file, why I prefer Excel, you know that it is very easy, just open the Microsoft Excel, and this blank worksheet is there with for you, and here it is blank and you do not have anything in that. Everything you have to give as an input, and then only you can get the output. So, first what is the magic square? Magic square is that you have to fill a 3 by 3 cell like that, 3 by 3 I can make it with boundary, and we can put it some. So, this is the simple way you can put these cells, and very simple way we can do, and this is the beauty for me using Excel, because directly you can work whatever you want once you know the sequences. So, here you can if you want that these are rectangular cells, so it is not exactly looking like magic square, just you can drag like that and you can adjust the cells, and now I think it will look like some square, and you can do it with entering the number also. Here right click on that, and here column width, and you can put that column width same to all 3, and like that you can put it. So, now what is to be done? The problem is that you have 9 numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9. These numbers you have to put in such a way that everywhere, every row, every column should have 15, some should be 15, and diagonal also some should be 15. So, this, as I told yesterday, what we used to do, we just used to put some numbers here and there, and trial and error, and matter ends there. But what Newton did, he has done first is calculated the average of these numbers. So, average numbers I am putting it, and this there is a formula for calculating average is equal to A B E. You see here it has come average, and then what to make average, that array you have to select, or that numbers you have to select, that is all. So, this is the average of these whole numbers, this is, and then sum. So, if you want to calculate the sum, there is another thing is that sum, and then select all the. So, all the numbers, when you fill this, it will be 45. So, what he has seen that his idea is that put this average in the middle. So, middle has 5, and then how other numbers you will display. So, here is the real challenge, and he has devised one method, means as I have seen in his book, what he has done, he has observed that these numbers are in arithmetic progression in AP, means all these numbers they should be in having a arithmetic progression. Arithmetic progression means the number sequence of numbers with a common difference, means if we subtract from term 2 to term 1, it will be some difference whatever may be 1, 2, 3, 4, and similarly third term to second term it will also be constant. And I think in class 6 AP is introduced, but when I studied in my school, I never realized that it has any use immediately in our daily life sort of thing. So, this is one thing when we teach or when you study in books, math books also some notes are given in brackets, but we always avoid to read that, but those things they are many mathematician life also mentioned in shortly, but we should read those things, then only we can learn the mathematics properly. So, here what is he has observed that this when we fill this total squares. So, what how much it will be? It will be 45. So, what he has devised one formula, I am writing that this d1 plus d2, and I am writing and then I will explain, then it will be easier to understand, but when we go directly to study that, and it is very difficult to understand actually how it comes. This is the mathematics in this magic square. So, what is that actually d1 and d2 means all diagonals, sum of the diagonal 1, sum of the diagonal 2, and then middle row and middle column, this all this add up, this will be w plus 3x. So, what is x? X is the middle number, x is the middle number. Now, let us see what is w. We know that w is 45, and what is d1? d1 means we know that all diagonals, all middle rows and middle column all add up to 15. So, this is 15 because sum is 15, d1 is 15, d2 is 15, m1 is 15 and m2 is 15. So, how much it is? All this sum if we do d1 plus d2 plus m1 plus m2 is equal to, I am writing this because a student whenever he will encounter, he may face problem how this is coming, from where it is coming. So, it is all adding up 60, and what is w? W is the sum of all the elements in the cells, and all the elements sum of what is we have written here 45. So, this is we are telling is 60 is equal to 45 plus 3x, sorry. So, 45 plus 3x is equal to 60. So, 3x is equal to 15. And then x is equal to 5. So, middle number is x and rest of the two numbers should be 2 x, and if it is required to be 2 x, that means 5. So, this diagonal elements, the first corner and last corner, that should be adding up to 10. So, you can put arbitrarily any number, arbitrarily from 1 except 5, 1 to 9, any number you can put here. So, suppose we put here 4. So, if this is 4, then 5, then it is to be in AP, arithmetic progress. So, 4 and 5 difference is 1. So, it will be 6. So, you can see this 5 plus 6 plus 4 is 15. So, this diagonal is okay. Now, here also you can put any number other than 4, 5, 6. So, suppose we put 1, let us try it 1. So, then 5 and 1 6, then it should be 9. And then I think this we will have to change here 6 and 4. And 2 like that, and then 8 and there will be 7. So, rest you can fill it very easily, 6 and 7, then it will be 8. So, all these numbers 1, 2, 3, 4, 5, 6 are all there, and now you sum up here. Auto sum option is there, auto sum option you can select, and you can see that it all add up to 15. Similarly, there are again you can use this auto sum, and these are the first example from Ramanujan book, and I have tried myself first, and these are the things I have written here. So, this blue color numbers is to be filled there, you can make it size bigger, and this sum is 45, means this is W is 45, and average is 5, and then write the average in the middle, then step 3 M1 M2 as I explained. So, D1 D2 like that. So, and this is the answer. But he has done lot of things, then this is the another thing, you have to fill all the cells with odd numbers and the sum should be 27. So, he has progressed in same way, that total sum is 81 and any row should sum up to 27 and average is 9. So, he has put 9 at the middle, and then rest you can do some trial and error, you will have a pattern, and from that you can fill this. And here also you can try this sum up. So, Ramanujan you can say 100 years back almost he has done all these things, and all you see adding up to 27. And next what he has done, here he has done when the row and sum column is 20, but these diagonals are not are different. So, you can see here diagonal is values, one diagonal is 16 and other diagonal is 19 and rest is 20 20 20. So, how you can do that? So, here also he has given some formula here, d1 plus d2 minus s by 3, this should be in the middle, and rest will be, you know that there will be some AP or something that can be done here. Similarly, here it is every row and every column having different sum, and diagonal also having different sum, and you have to fill these cells with 1 to 9, and that also he has calculated like this, and you can see this. So, what I am encouraging, I am not teaching this how to do this magic squares. My motivation is that a student get interested on that, and they have these tools with them. So, they can go on exploring as much as he can. He want to go or she want to go as much as possible, let him go, and we are not insisting. I am showing that these tools are available. These tools were not available at their times. Neither Ramanujam had this, neither previous mathematician had this facility. So, once you do that, lot of work still can be done in these magic squares. A lot of you can get PhD even, and you can get many awards if you can find out some of the uniqueness and some of the special characteristics which we have not discovered till date. So, this opportunity is infinite, I should say. During my school days, I used to think that everything has been discovered and nothing is there to discover, but it is a very wrong idea. It is not like that. Now, you can say we have discovered few ideas. There are hundreds of ideas yet to be discovered. So, you can also can be a person who can engage on that. Then here what he has done, Ramanujam notebook 1 page 2, he was saying here means these are rectangular thing, rectangular means 3 by 4 squares. So, how to fill that, and he had given one idea. He has given, you see that yellow color A, B, C, and the rest will what will be the ideas formula. Here he has given A plus C is equal to 2B plus 3D, and from that you can calculate the D values, and suppose you have A is 1 and B is 5, then you can calculate C and 1, this ABC is given, then D you can calculate from that, and from these figures are given where to put these figures and what will be the result. You can see that all the rows and columns are rows are all 35, columns are all 24, rows are 32, and diagonals also 24, like that you can see. So, now next what he has done, he has done this 4 by 4 square, and 4 by 4 square this he has taken two set of number letters A, B, C, D, E, F, something like that, and P, Q, R, like that he has taken, and he was trying to fill the cells with the combination of A plus P or A, C plus S, like that, so that no number will repeat in this cell. So, you can get a unique number in all the cells, and similarly he extended these ideas in 5 by 5 and more. Then how to calculate, this is the trick he has explained, and you can complete that. I have not done it yet. And then coming back to the Nagarjuna, I told you as I was surfing net that Kaksaputa his thoughts and 10th century CE, that means around 1100 years ago, and Kaksaputa what meaning is saying that enclosure of a hollow space, means what I feel the cells they are trying to represent with this. Oh, some portion it is not appearing, I think. Hello. So, this sutra he has given now it is okay, I am just reading it. He has given some during their time they used to use some symbol things. So, Arka is 01, Indunidha 0809, Nari 02. So, this is the code numbers he has given. So, he has given that what should be the this is 4 by 4 no. So, 16 cells what will be the 8 cells he has given, this 8 cells values he has given, and he told these bottom cells, these are the cells, he has told that you can fill these cells in with n, and these are the cells and n can be any number. He has done it for any odd number and any even number. Here I have calculated for n is equal to 100, and what will be the, if n is equal to 100, then n by 2 is 50, and all the calculation are based on that n by 2, means this 50, and this cells what filled here you can see this original cell 1982, all these are remain same, and this is true for any odd number as well as even number, but odd number if you go this will become not integers and all will become fractions. So, that is not desirable. So, this cell is not magic square is not for even number formula he has given separately, just I am mentioning here. So, here in slider yesterday I have shown that slider, with that slider now you can change the values of n, and you see this n is equal to 46, then what will be that, and you can see that here the beauty is that this n, when n is all even number, then you can fill this, and all these addition, subtraction, rows, columns and diagonals all are adding up to 84. So, this is thing, then if I go for 40, suppose this is 40. So, it is 80, all the rows and columns will be 80, and this is not only that, this any of the diagonal 4 elements if you take, this 4 will add up to 80, this 4 cell will add up to 80, this 4 cell will add up to 80, this 4 cell will add up to 80, and this center cell, this is also will add up 80. I have shown all these calculations here, and in the middle also this portion will be of 80, and then again these 4 they also add up to 80 like that. So, so nicely, but we do not know what was the basis of this 1892, that means this is called Arko, Indunidha, Nari, Tena, Lagna and Vishwa Sanam. That is not known to us. This is, it was his discovery, that if you these numbers are filled with this, then it can accommodate any even number magic square. So, so nice of these things. and manually when you read this and try to learn this, it is very difficult to understand what actually it conveys, because we are not doing anything, no. So, we do not know what purpose we are doing that and why we are creating that magic square. They had some background about calculating these things. So, they know why they are doing, what for they are doing and what they want to achieve. So, they had, but a normal student when he encounter all those things, then first thing particularly I try to understand any new thing, and first thing we face the problem is that why I should do that, why what is the requirement of doing all those things, and so nicely it can be done when we use the technology, and with the technology it is so nicely I could make it. I was very happy, and I could give color code also to explain, and anyone can do that. And these things can be extended to Sudoku and any other number games and any other things, and Excel can be used very easily without any problem in solving this. I will show another example about this. This problem I encountered when I was looking for this magic square. So, I was searching for magic square and lot of things were coming, and from that when we so, here in Wikipedia you can see so many items about this magic squares, and depending on your interest you can explore this. So many things are there. This is another Lao Shu magic square. This is a unique magic square, very famous, and while sharpening this, I have encountered another magic square. This one, a method for constructing magic squares of order 3, and in 19th century Edward Lucas devised a formula. This is the formula, and I will show it now. This formula I have today I have made this magic square, and here I what technology can do, I want to show that. This is the formula, a method of constructing magic square of order 3 by 3. This Edward Lucas, and formula is C minus B and C plus A plus B, C minus A, like that he has given the formula. So, these 9 numbers will be distinct positive integer. So, they should be first positive integers forming a magic square with magic constant 3C, and so long as A less than B and less than what I should say here. This is the formula. A should be greater than 0, but less than B, and C minus A should be greater than A and B both, and B should not be 2A, and moreover every 3 by 3 magic square of distinct positive integers is of this form. So, this is also there. So, what I have done, I have taken these numbers A, B, C, and these numbers I have put some arbitrary slider, so that I can change this A, B, C, and condition I have put here. You can see this condition, if this is less than A, then there will be no solution, or if it is, then there will be solution. So, from these numbers it will tell you that whether these numbers are okay or not for these 3 magic square, and then once this is okay, then it will give the results, and all this add up is 144 here for this combination of number. A, B, C is 20, 26 and 48, and C minus 28, and 28 is greater than A and greater than B both. And if I can add up this diagonal, I have not done it, let us check whether how much it comes. So, it is diagonal also 144. So, these are the things, and I wanted to explain all these things to you, because you start doing your own magic square. There are hundreds of magic square, and you cannot, need not stress your mind. Now technology is there, you know the formula, how to use it, and you can use, and once you understand what goes on, then you can create your own magic square. So, this is today for magic square, and next what I will be doing, I will be explaining the method of creating a tetrahedron first physically and then mathematically. I will explain how this physically we can do, and then how we can do it geometrically, and what is the difference between doing something physically and doing something mathematically. That also you will understand then, and with that I will start my next presentation on making a tetrahedron. When we talk about making a tetrahedron, 1 minute. So, this is the tetrahedron. I will be cutting this tetrahedron, and from this this is actually in for creating a tetrahedron, what we require? We require we can do it physically very easily. What I will be doing? I will cut this as a equilateral triangle, and from that equilateral triangle, if I fold it, we can make a tetrahedron, and this is very easy. And then I will do same process without not physically, we will do it mathematically. When we have to do it mathematically, then I have to tell the computer or laptop what to do. They do not know, they do not have any brain, or they do not have this physical piece also. They will be doing whatever may be available in the screen, the laptop screen or desktop screen. So, it is a 2D object, and they cannot make it 3D. I can physically make it, show it 3D. So, they have to make it 2D plane, they have to show create this 3D tetrahedron, and it should look exactly like a tetrahedron. So, this is I do not think today we can finish it, but I will discuss it, I will tell the difficulties about it, and I will tell you the process to be followed for it, and you can try it. and tomorrow onwards I will be visiting again, as I told you that I have given that 35 schools. So, I have to visit those schools and I will be coming back with next, and in between if anyone see these videos and they can create this tetrahedron geometrically, then I should say that my effort is successful. So, let me start with this one paper, and so what I will do, this is the paper, and I have taken a little bit harder paper with that, and I will put it कांची कहाँ रखा, कांची रखा था कहीं. So, this is the paper. I will create a equilateral triangle. Creating a equilateral triangle is not difficult. You can take any piece of paper, you can draw a line, and then you take with compass equivalent radius of this length and cut to arc, and this intersection point you joint with that, you will get the equilateral triangle. It is very easy. So, I will be cutting it. Just I am showing I had a marking. So, I need not measure and all those things. So, this is a equilateral triangle, you can say, and what is to be done? First I have to find the midpoints of it. So, how I can find the midpoint? I just fold it and I just press it a little bit, in that way I get the midpoint. So, I am doing in physical model. So, I got the midpoint of this edge, and then again I will be doing same thing for other edges. So, all these 3 edges I will be putting it. Just I am trying to explain the process required for physical model creation, and at the same time how it can be performed with a geometrical modeling. So, I have these 3 midpoints. I will now add fold these midpoints as we do in origami sort of thing. No, we fold these edges. It is very simple to do, and anyone can do, and though it appears very simple, but all the big things starts with similar simple thoughts. So, if you can add this all vertices, then this is a tetrahedron. It has 4 vertices, a 1, 2, 3 and 4, 4 faces, and 4 and 1, 2, 3, 4, 5, 6. So, 6 edges, and there is a formula for this, how many 4 face Euler formula in 3D, this face and this vertex having how many formula, you can calculate that. I will explain all those things in later days. So, here so easily we got this tetrahedron. Now, I have to make it geometrically or mathematically in computer. So, I cannot tell if you use some software, they will do for you, but I want to learn mathematics behind that, and I want that this mathematics mathematically I should able to do that, then any model I will do. So, what is required first? I have to tell the computer, no, one after one I have to instruct computer, you do that. So, what I will be telling the computer, I will write there in board and explain what I will tell, I have to tell computer, and the language that should be what computer understand. So, what will be that? Let me see the board, and exactly we have to do that. Let us put it, this is creating a tetrahedron geometrically or mathematically. These are the terms, geometrically or mathematically, means because there are mathematical model and geometrical model. Mathematical model, actually there are some issues are there. Mathematical model, what is mathematical model and what actually we are doing, whether it is a mathematical model or not, there is some controversy. So, I tell it is geometrical modeling, it is not mathematical modeling. So, what I should tell the computer, do that. So, first thing I have to tell that, take a point. So, I have to tell all these things. So, then join this point. Then take another point. take another and join. So, this are the things. So, what I told it geometrically, I told take a point, then take another point, join this point, take another point, take join this point, then join this point. So, you do that. So, computer immediately what will ask me that where to take this point, how to take this point, and what will be the length of those points. I have to give all the details to the computer, and that computer then it will take and plot it for you. So, this is the first step. Then after that, what I have done there, I have folded it to find the midpoint. Here also we require that take, I think this is 6 point. Take midpoint, then of all edges I can instruct them of all edges. So, then I am telling it take so I had this triangle, then I asked it to take midpoints and then join these midpoints, and this is a thing. So, next what I will tell, fold the paper or fold the object. Whatever may be, means I will ask them you fold it, this fold it and this fold it. So, once I can instruct them properly, then it will do, and then we may get a sort of like that tetrahedron sort of thing we may get. So, this entire activity we have to do it in our Excel file, and Excel as I told you, Excel is the most easiest software to do everything, because it is the spreadsheet is given and everything you have to do. So, you require to learn every aspect of this, how to do that and all those things. So, with that I will be demonstrating these ideas. But before that I think we should take a break, and after break we will start our Excel file. And with this I will be closing this first session of third day, and tomorrow I will be visiting some DO office and schools at Aravalli. Then I will try to go to Chote Udaipur also, and meet some school officials and students, and anyone can solve this, they can contact me. I have given you my contact number yesterday, today also I will be giving you. So, myself Chanchal Das, and you can reach me at 8320172787 and CD gmail.com. It is not required that you can ask questions related to my topics and any other ideas. Anything if you want in science and mathematics related, you can post me, you can write to me, you can WhatsApp me, you can call me also if required, and those answer I am having I will readily provide, try to provide, and those are not having to with me I will explore for you, and I will give a satisfactory answer for that. So, with that we will be closing today, and thank you, and we will be after short break we will be again joining with Excel files. Hello, good evening. Welcome back to our second session of third day interactive TV show on mathematical concept. So, this is a unique program and I hope people will enjoy this and program, and in future they will see that effectiveness, because I am trying to promote a new way of mathematics, and this mathematics teaching in a macro scale. Macro scale means overview of total mathematics. So, in a practical problem we will try to learn mathematics. So, in doing that I was telling we will create today a tetrahedron, and in doing that what we have done, we have developed one explained this is the process, and physically we have created a tetrahedron physical mode. Physical mode it is very easy, but same thing we have to do it in geometrically or mathematically, and that I am trying to do, and the process I will explain today first, and after that I will do it in Excel. So, in the process I will be explaining how these things, how to take a point, add another point, join these points, then take another point, join these, and like that. If we go like that, then join the midpoints, and how to take the midpoints, and how to do all these things means, and all we will not do with any formula and anything. We will have to put it mathematically, we have to put it numbers, and we have to calculate the desired points, and midpoints also we have to calculate, join it as we learned plotting in Excel like that, and then we have to apply all the transformation to transform from a 2D paper to 3D tetrahedron, 2D triangle to 3D tetrahedron. A lot of movements are there, and all those movements how we can do, and this is the actual drawback I should say in our method of teaching mathematics. We do not have any tool to explain that. Frequently we have to tell the real life problems that you move it, you rotate it, but how to move and how to rotate, there is no mathematics. If we require to do all those modeling, we have to go to any software, but without any using any software I should able to do it myself. So, how we can do that, that is my expertise, and I am trying to teach that part. Rest you know, this all this talk whatever I have done till now, everybody knows up to this, but how this can be applied in making this 2D to 3D. So, first we have to create a take some points, and we have to finalize the length of that equilateral triangle, and accordingly we should take. And yesterday I told that in any square grid we cannot put any polygon other than a square in the nodes. So, that square nodes, if we take a graph paper like that, it will not help to put a equilateral triangle somewhere. This will not be an equilateral triangle, but we require for polyhedra we require an equilateral triangle. So, for that what is to be done? I will do that with some mathematics involving trigonometry and polar coordinates. We require x and y, but directly it is difficult to find the x and y values for a equilateral triangle, but with the help of trigonometry it can be done very easily. And how this trigonometry help it in that? We have to use the polar coordinates. Polar coordinates means r and theta, that will define our points, and we will take that in convert it in Cartesian coordinate and we will get. So, first thing is that we will take a equilateral triangle whose length is r. R is equal to, suppose any value, I am taking 6, and we start from a point which is easy to locate. So, here in x axis, if I take theta at t is equal to 0, then we can write x is equal to r cos t and y is equal to r sin t. So, here t is equal to 0. So, r cos 0 means 1. So, x is equal to 6. So, we will get a value 6 and 0. Now, we know that this equilateral triangle, this will be the 60 degree. So, this is x 1, x 2 point, sorry, this is y 2, y 1. So, similarly, we can take t is equal to 120 and T 2 we should say it is T 1, T 2, T 3 is 240, this is 240 degree from here, and like that we can create our both. In all the cases this formula will be same and angle will go on changing this is degree, this is also degree. So, we will get this value here x 2, y 2, x 3, y 3. So, like that we can calculate these 3 points and we need not manually calculate this, put these values. These values are available from our geometry. So, that we will be using, and trigonometrical formula we will be using those and we get this. Now, how to get these midpoints? Midpoints, this is a very easily we can calculate this midpoint. Suppose it is x 4 and y 4. So, x 4 is equal to this one x 1 plus x 2 by 2 y 1 plus y 2 by 2. So, this is midpoint of point. Suppose if we put it point A, B and C and this point is D, then D will be x 4 y 4. Similarly, this point x 5 y 5 and let it be E, and then another point will be here. that is also calculated midpoint E f x 6 y 6. So, these values A, B, C, D, all these values we got, and when you join we got another 4 equilateral triangles of a smaller size. Now, what we have done in physical model, we have folded from this, if we change the color code, we can this is one part, this is another part, this is another part. So, if we fold these 3 parts from respective foldings, then we can create this tetrahedron. So, this is the thing, and as I am trying to connect the mathematics with our real life, then this when this problem comes for folding. So, what is the mathematics of folding? There is a book, very nice book, How to Fold, and think of a world where you cannot fold anything. Then this life will be miserable life. Without folding, we cannot move, we cannot speak, I cannot do all those things. So, there are lot of mathematics involved in folding. We never realize that there is a mathematics also involved in folding. And once you go for a what I should say, a robotic sort of thing, making a robot, and robot will also have same hand, or for the same sake for our hand. So, we can think that how we can reach, where we can reach to reachability of our hand. We cannot reach even with this hand, we cannot reach this portion, and similarly we cannot reach many of our portion even folding, and these are the constant. And when you create a robot also, it having some robotic arms, and it is supposed to take them one position to another position, and you have to give the programming instruction how to do that, and then you have to read reachability area, which area it can reach, reachability angle, which angle it can reach, and reachability the position where it can reach and where it cannot reach. So, accordingly many calculations are there for that, and it is a very fascinating subject in mathematics, the mathematics of folding, and someday I will also discuss on that, but this is also required folding from here. So, now geometry we have understood how to do that, and now we require to do translate it into mathematics. So, what is the mathematics? So, mathematics if you know that, then you can calculate the everything, you can make the model. So, now I will be talking about mathematics. I have this triangle, and I have folded it like that, and now I have to move it. So, how to do this? So, this part, when we make this part, I tell that this part is for modeling, this part is for modeling. Now, we have to fold it, that means we have to transform it, and all the transformation we have learned first day, everything is required here. So, how what are those transformations? I will list one by one, and with this 6 transformation you can move anything anywhere. In general, in our real life problems you can solve any type of movement anywhere. So, what are those movements? One is that this is scaling. Scaling in the sense, if you have an object, you want to make it bigger or you want to make it smaller, how to do that. So, scaling. Then you can use shearing. So, uneven enlargement and contraction. Uneven means you cannot predict how it happen. Sometimes two cars make an accident. So, what will be the shape you never can predict. So, something like that, shearing. Then reflection. Reflection, if we stand somewhere, then our image reflected with a mirror, and that is also a one type of movement, and it has having many peculiar properties. And then rotation. So, all these things having very easily can be performed, as I described first day, that any point, suppose you have a point x and y, so this is one row 2 column, one row 2 column. So, in this can be multiplied with a matrix which is should have number of columns should be equal to the number of rows, that is first requirement. So, you require a number A, B, C, D sort of thing. So, here if it is 2 column, here it should be 2 rows, that is first requirement to have a matrix multiplication. So, this is the matrix multiplication. Then what will be the result? Result will be, this is A x plus B y, and this is C x plus D y, another term. This will be again as it is 1 by 2 matrix, then if we multiply it 2 by 2 matrix, then you will get again 1 by 2 matrix. So, this is the general form of matrix, but as the number, suppose here is 1000 points, 1000 x and y. Okay. So, all these 1000 points can be modified by this simple 2 by 2 matrix. This is the uniqueness. Okay. So, and all these points can take changed and transformed, and the object here, what will be the object when multiplied with these 4 elements, it will be transformed to some other object. So, this is the beauty of matrix transformation. So, this is the second. First thing is the creating this model, second thing matrix multiplication, and then third thing is the putting some putting some what I should say slider for animation, these things. Now, how this helps? This ABCD, depending on this values of ABCD, all these movements can be achieved, and many things we learn linear algebra, but this is also learned subtly without we even know that what it does. We mechanically we learn these things. Now, for scaling, what is there? First, if we tell identity also a identity means I do not want to I want some number like 1. When we multiply with that number, it will not change, the number will remain same. So, something is required for matrix multiplication also. So, we want some matrix which when multiplied it should not change. So, what is that identity matrix? This is also a 2 by 2 matrix 1 0 0 1. Okay. So, this is the identity matrix. Now, what is scaling? These diagonal elements, say 1 and 1, these diagonal elements, if you put some values a 0, 0 and d. So, depending on this a and d, this here uniform scaling means these both are should be same. A. So, A depending, if it is more than 1 it will enlarge, if it is less than 1 simply it will contract or scale down. Similarly, here some values, if there is any values A, D, B, C like that, any values, then it will help in sharing. And for reflection, -1 0 1. So, this is you can see in this case what will happen, all x values will change the sign, negative sign. So, the result will be for that that it will shift to the left side of y axis. So, this is called y axis reflection, or similarly if we change it like that 1 0 0 -1, then it will reflect about x axis. So, this is there. And then rotation again, yesterday I told it that rotation is cos t, t means angle, sin t, minus sin t, this is anticlockwise, this is rotation. So, with these 4 we can easily apply this rotation. So, and all these are 2D except reflection. Reflection in general happens, it comes out from the 2D plane and again goes to the 2D plane. So, it is not visible how it is going, but actually it is a 3D phenomena, but in general it is also a 2D display. So, it comes with 2D and goes to the 2D reflection. All others are in you can say it will be in 2D also. Now, what are the two important transformation are there that cannot be done with this 2 by 2 matrix, and here actually the point where I am deviating from the conventional way. Up to this many student or many books covers, but this next topic, this is in general being taught in computer graphics subjects, not in general stream. But I think that these ideas should be taught to school level also. So, what is that? It is some ideas about homogeneous coordinate. With Cartesian coordinate system, it is very difficult to achieve translation. Translation in one way very easy transformation. I am not going in depth on that, but translation is difficult to achieve here, and projection. So, for this too we require some new method which is called homogeneous coordinate system. Till now we are in Cartesian coordinate system. So, what will be the new ideas from me? This homogeneous coordinate system. I will save this. Okay. So, till date we are doing this is the two difference homogeneous coordinate. Homogeneous coordinate system I think 1857 or 55 Mobius developed this system, and in general we are not using it much in our school and colleges except computer graphics. I do not know even computer graphics how much they are using, but this is a required system. Why it is required? That one there are many reasons why it is required, but I will cite one. What is that one? You see that our origin is 0 0. Now, if we want to transform it, so anything you multiply with 0 0, it will be 0 0. So, greatest drawback with Cartesian coordinate system. If our we have made some model with origin at 0 0, then that point we cannot move, and all the transformation if we apply, then the object will be transformed as per those values, but the origin will remain constant. So, it will get a distorted result of that homogeneous coordinate system without homogeneous coordinate system. So, for this actually main use of this homogeneous coordinate system are introduced. So, I am not going in details about the theories, I am just telling the why we require homogeneous coordinate system. So, in homogeneous coordinate system, the origin is 0 and h. H is another element has been added, and that has made our life very simple. But what is that h actually? It is very difficult. Initially I also confused, and many people I talked later, they also have a confusion about h. Many people think that it is z. It is not z. It is you can say it is another 2D plane in some h distance. So, if suppose another system. So, this is one homogeneous system which is 0 0 h, and this is another homogeneous system 0 0 h 1. So, depending on h 1, these values of these two planes will differ. That how much it will differ depend on your ideas about h, and in general we take this h is as 1, and rest we calculation we do with that. And in this case what happens actually, you see this problem of multiplication will not be there, but again there will be another problem, because here the element is 3, or now we can put it x y. This is x, y and h. Now, we have 3 elements, and when it is a 3 elements, then first condition is that this number of columns should be number of rows in transformation matrix. So, A, B, C, D, E, F, G, H, I. So, it should be minimum 3 by 3 matrix. It will be a square matrix, but 3 by 3. So, this is the first requirement for matrix transformation. So, in this case what happens, this first 4 elements, this whatever transformation they are doing in these cases, this operation, this they do as usual, there is no change, but these 2 elements, this is translation in x direction, this is translation in y direction. So, if you use this homogeneous coordinate system, so directly one matrix multiplication, it will help you to translate here and there, up and down. So, whatever you want you can do that. So, this is the thing advantage you get, and these two E and F, these two is for projection. So, projection it is not immediately required for us for our calculation part, but all others are required. What is we require rotation, we require translation. These two at least we require for our case. So, for achieving these movements, actually I am doing this for this purpose. So, earlier I used to teach all these things without any practical use. So, now I thought that let us have some practical use, and I was trying to do it for a long time, but it was very difficult to do, because I was doing in polyhedra all the Platonic solids and other Archimedean solids I was trying to do, and it was getting very complex, but now at least I could do it. So, now these are the things up to 2D. You know that what is the identity, what is the scaling, what is the shearing, what is the reflection, rotation, translation and projection. Initially it may appear that it is very difficult, but if you go on, because this is the repetition, any modeling you require these 6 things, any not 6 all, any one of or 2 or 3 out of that, and then I will explain this by for using 10 gram puzzle, T puzzle and all those puzzle, how to do that, and sometime we may use it for other purposes also, but this 6 will be common, and this is all done by a matrix multiplication. So, once you go on doing it will be very means I enjoy, at least I being a mechanical engineer, I can penetrate any type of mathematics related to any branch. So, this can happen. So, this is the thing. Now, how this help? Before moving again, we require some additional things. What is that additional thing? Additional thing is that we are moving in moving in 3D world, because we are working on 3D. Okay. So, these tools we have used for 2D model. We can rotate, we can translate, we can reflect, we can shear, we can scale up, scale down, everything we can do. But how we can go with that in 3D? So, 3D, what is the main problem in 3D? 3D having a point is expressed in 3D x, y, z, and this is Cartesian coordinate, and I told that is Cartesian coordinate. Again, if my point is in origin, then we cannot move it, we cannot transform it. So, we require some new system where we can do that. So, how we can go for it? So, that is also a simple extension of these ideas. You put here H. So, all the pattern what we followed in 2D are here. Only thing we added one extra element in the matrix. So, x, y, z and h. So, this is the homogeneous coordinate system in 3D. So, we require all those transformation corresponding to that, and for that we have one tool, and that tool is matrix multiplication, that is all. So, if you know the matrix multiplication, that also applicable here also. So, what is required here? It is 4 column. So, you require a 4 row minimum. So, and it is a square matrix. So, it must be 4 by 4 matrix. So, you require a 4 by 4 matrix, that is all. So, A, B, C, D, these are the elements E, F, G, H, I. So, this is the thing, and when you multiply this, whatever you get x star, y star, z star and h star, that is all. So, your x, y, z will be transformed to that, and that is required because you have to fold it, and you have to make a 2D object to 3D, and that you have to do it, tell the computer to do that, and you have to give every information the computer to follow and produce for you. So, now how this will help in those translation, transformation, all those things. So, this here also with this sorry. This red color elements, these elements are for scaling, shearing, reflection, rotation. Okay. So, this we can do very easily for and the row line here blue, oh sorry. Translation. So, this can be done. This is M is x direction translation, moving left and right, n direction means y direction, x and y, up and down, and O means z direction, near and far. So, these are the translation, and remaining thing is that make it black. This is actually projection. So, all the transformation we can do in the same way. So, whatever learned from first day to today, everything is intact, nothing has changed. The only thing we have extended the scope from 2D to all the transformation up to 3D. So, this will be required for accomplishing our projects in converting a equilateral triangle to that tetrahedron. Now, again I will explain how to do that, because here whatever we have done, we have some limitation. What are the limitation? In 2D, suppose this is a 2D plane and I have an object like that in 2D. So, this is x and y. So, how we can rotate it? When we rotate it, it rotate like that, it comes here, it comes here, it comes circular, it goes there like that. So, it moves in a circular way. Okay. But problem is that, what is the problem we will face? Suppose you have to rotate it from some point. This same object you have to rotate about this. So, how to do that? This is the challenge. This will also, when you rotate this object, then it will let us take a nearer object. Suppose this object is there and you want that this object should rotate about this point, not this origin, but we have this cos, sin, minus sin, cos. So, this matrix you have that can rotate any object about origin, but if you want that it is not origin, it is x 1 h and k any value. So, it has to rotate like that. So, for that what we can do? We have to take this point and this object to the origin. So, it will be here and this object will also translate here. So, here we will apply translation, we will translate minus h minus k, then it will be coincide with this origin 0 0, accordingly it will shift here, then we will rotate it, because we know that how to rotate it in through origin. After rotation again I will take it from this point, we will add h and k to take this system back to here. So, how we will do that? We will apply a translation TR translation to take it here, then rotation, rotate it, and then we will do inverse translation INV TR. So, these three operations we do. So, we can achieve this rotation here. Another problem we will be facing when we try to rotate objects in 3D. In 3D there is an issue of rotation when this object rotates. So, how this object rotates? Because when this object rotates, all x, y, z get changes. In 2D we can accommodate that in 2 by 2 matrix. In 3D there is no formula, there is no sin square theta plus cos square theta is equal to 1, that formula is not there in 3D. So, it is very difficult to accomplish a rotation in 3D, but the scientist and mathematician, they have devised some method to solve this problem also. And this how they have solved this, you can see when any object rotates, suppose this 2D object rotates. So, what will happen? 2D, this is x and y, suppose this is x and this is y. So, where is the z? Z is the center in this, coming inside or outside vertically away from the board. So, in that case you can see that z remains constant. Okay. So, z does not move. So, we know how to move a object in 2D. So, same thing z will not move in 3D, all this x, y, z does not rotate simultaneously. That is the first finding, and these are the crucial findings, and from that we can this will make our life very very simple. So, we need not bother about that, we know that in 2D rotation can apply in this 3D also. And similarly, suppose I want some object to rotate in that is required when we try to rotate here, no. So, sometime we want to rotate it like that, sometime we want to rotate it like that, someone because we have to rotate it, then only we can create this tetrahedron. So, that rotation also required some treatment, and this observation will help us. How it will be? When it is in we will rotate in y axis, then the x and z will move, and when it moves in x axis, then y and z will move. and in this way we can accomplish all the rotation from 2D to 3D, and this is the technique what we can apply, and I will show this. I have already tried it, and I have done a little bit in Excel and a little bit in MATLAB. Today I may not finish it. Next time when I meet again, I will explain how to do it. Today I will show just a few thing in Excel and MATLAB how we have done it. So, with that I will be going to that yes. So, you can see this I have made this in Excel, and this equilateral triangle I have created, and in I have midpoint I have calculated, and this lastly I have to fold it, and so these are I have first day I have shown this how to do this scale of shearing, reflection, x reflection, rotation, then creating a point, then this, okay, and then so I have to apply this I have created this, and now I have to apply this 3D rotation as per requirement, and these are the movements I have created here. First calculation, all these calculation are for finding the points, and after that points I have calculated so many things, but it is not yet complete, and I have to do something extra, but the method is same. All the translation, rotation, all has to be done with this matrix multiplication. So, with that I will be showing this is the operation in MATLAB, and you can see I have shown it how this has been done. And the code, if you think how this code has been started, so this is the base triangles, and then I have to make it as a required for this rotation. So, first that green piece that is I require to shift, and for that I think this is shown here, and if I have if I use this, then one by one you can see that how you can see this brown color portion that I wanted to fold, but I do not have any technique to fold it with along this line. I have to fold it in the baseline. No, this I am showing with my cursor according to this line, but I can rotate it about x axis. So, what I have done, I have translated it green piece, that brown piece I have translated toward the and make it coincide with x axis. Now, from x axis I can apply rotation. So, now this green portion I will rotate, and rotation angle I am describing here. Next, this is 109.5 degree we have to change. This is dihedral angle, it is called. So, outer angle is 109.5 and inside angle is 79.5, I think 79.5, 70.5, sorry, 70.5, not 79, and then at that angle I have to rotate it. So, this is the rotation matrix what I am calculating. I think it is visible there. And then I backslash, then now you see this blue color was translated this one, and then I have rotated it. Again I have to take it back to this original base, that is also there. So, this all these things have been done with matrix multiplication. So, what I have done, you see this inverse translation, this AAA, here I am applying inverse translation INVTR XTR, and then if I plot it, you will see this rotation. You see this brown portion rotation. So, now I have shifted it back to its original position where it is supposed to rotate. So, like that if you do in other two segments, then it will be a now you can see I have shifted to portion also. Now, it is tetrahedron, and third side if you add, I have kept it open because for showing it. So, in this way we can make mathematical modeling very easily, and can be done, and you need not stress your mind, because all these things can be done very easily using computer, and x, y, z, all these things can be done very easily. And this I have I am showing it in MATLAB, but it is you can do it in Excel. Excel there is some extra issues will be there, but that also can be sorted out, and that is the key point for my success in converting any 3D object in 2D. I will go to the board and I will again explain how I have learned these things, and from that you will get an idea about how we can think of 3D objects in 2D. So, what is required for an object to be displayed in 2D, which is actually a 3D object. So, I will be sharing that. So, major problem what we face in this mathematics, capturing the 3D world. So, I am also was not an exception, and I told you that in 1999 I learned 3dx Max, which is a animation software to learn mathematical concept. My idea was that if I know this 3D, how this 3D works, from that I can get the knowledge how it is being done mathematically. But when I learned after that, I could make all this modeling, I could make my that time I was with ONGC, and many of my presentation I used to make it 3D model and present. So, that time even PowerPoint was not that popular, and that time all these where we dig the oil well under the earth, and then how this oil flows to the surface, how it goes to different pipelines, everything in 3D, and camera moving in that like that. So, it was very interesting, but there I could not learn the mathematics behind all those things, as I told you earlier. So, my effort was on, and I was trying to accommodate, and the major problem is that in 2D plane we can draw anything. So, we can draw any object. So, but problem is that how we can draw a 3D. Here we can write x, y, and any point anywhere I can plot, and I can do anything. Any object we can do in 2D. So, how to accommodate z? That was the problem, and I was very much worried about that, because I wanted to show the object 3D. I could model it, but mathematically I cannot play with that, as I have done today in MATLAB, as I shown. I have given the formulas, I have rotating it, I have translated first, then rotated, and then retranslated back to its original position. Like that, it is very exciting and entertaining activities, because everything I am doing, and I am doing what I want. And similarly, many people having many ideas come in their mind, and they what they do, they try to make physical model, and physical model is very costly, and it is not only costly, it is very difficult also to give a shape. But in mathematically you can do anything, whatever you want, and that was the beauty that I have started learning. What was the ideas I had, I could give a shape on that. So, that period I was very frustrated, real sense, and I was thinking how to accommodate z in x and y. And suddenly one day I was I had a presentation on some cube, and I was thinking that cube, and you see this so, I was as we see this is a cube, and okay. suddenly the point struck in my mind, this is not a cube, this is a 2D object, and I am fooling myself thinking that it is a cube. And then the main exploration started about that means this depth perception. I have to do something depth perception, and how to do that. Then I started focusing on that line, and I got one book I should name Roger and Adams. Anyone interested in mathematics on they can also Roger and Adams. In Roger and Adams, this book I got in IRS ONGC library, and this book was written very thin book, and it was a very old book, also discolored almost and lying in a library rack. And I thought that it is of no use, but when I opened, I have seen that it was written very early days of computer graphics time. So, many of the ideas has been elaborated very nicely, and that helped me to give the shape of 3D. And now, here we are plotting this 2D in 2D plane, but we are adding 3D depth perception, we are adding on that, and it appears to us that it is a 3D object. So, how to do that, that I will be discussing, we will discuss our next meeting next week. And meanwhile, these ideas I have given, any student interested on those things, they can try it, and if they can explore these ideas themselves, then you will find the enjoyment of real mathematics. So, that is my suggestion, and with that I will be stopping today, and next day I will explain how we can do it in Excel. We can animate, we can we will fold all those 3 edges, and we will make the tetrahedron 2D paper to 3D polyhedra. With that, thank you.